I want you to imagine locking your most valuable secrets in a safe.
Okay.
And you're sending this safe across the world.
Right.
Now you've got the best locks on it, so you feel entirely secure.
Sure, because nobody has the tools to break those locks today.
Exactly. But what if the thieves who are intercepting that safe, what if they aren't even trying to break into it right now?
They're just taking it.
Right. What if they're just hoarding these safes in massive warehouses, just, piling them up to the ceiling?
Waiting.
Yes, waiting. Perfectly content to sit on all this locked, unreadable stuff for 5, maybe 10 years.
Just waiting for someone to invent a completely new type of tool to crack them open.
Exactly. It sounds like a paranoid sci-fi movie.
It really does.
But it is the active current reality of global data security.
It is a totally sobering reality. And look, it fundamentally changes how we have to think about the lifespan of our data.
Yeah.
So welcome to our deep dive. Today, we are analyzing a really critical shift in the cybersecurity landscape.
A huge shift.
Oh, absolutely. Our source material today is this incredible detailed breakdown and a webinar overview from the Hacker News.
Published on March 5, 2026.
Right. And the focus is on post-quantum cryptography. It provides this incredibly revealing look into how major security platforms, specifically Zscaler, are preparing for what is essentially an architectural earthquake.
An earthquake in how we protect digital information.
Yes, because our mission today is to decode this really terrifying new cyber attack strategy that is already well underway.
We really need to understand why our current heavily relied upon methods of encryption are basically operating on a ticking clock.
A very fast ticking clock. And most importantly, we're going to explore the practical steps that organizations are taking right now to future-proof their data.
Okay, let's unpack this, because I think we really need to start by confronting the false sense of security that most of us operate under.
Well, the assumptions we make.
Right. When you, the listener, initiate a secure transfer or you access a highly classified internal network, you just rely on established encryption.
You see the little lock icon and you feel good.
Exactly. You assume that because the data is scrambled now, it's secure forever.
Yeah.
But this analysis we're looking at today just shatters that assumption entirely.
It does. It points directly at the rapid advancement of quantum computing.
Right.
The source specifically names 2 standards, RSA and ECC.
And for anyone listening who manages networks,
you know exactly what those are. These are the asymmetric encryption algorithms that, frankly, hold the entire modern internet together.
They really do. They rely on these incredibly complex mathematical problems.
Like prime factorization.
Right. Math that would take a normal classical computer, millions of years to solve?
Millions. But quantum computers don't process information linearly. Because of how quantum mechanics work, they can solve these specific mathematical problems exponentially faster.
It's just a totally different paradigm of computing.
It is. And the definitive statement coming from security leaders right now is that because quantum computing is advancing so rapidly,
RSA and ECC will not remain secure.
No. The math will simply be broken.
Which brings us to the warehouses. Or I guess the server farms full of gibberish.
Yes, the hoarding.
The Hacker News overview highlights this specific tactic being deployed by state-sponsored actors right now.
And advanced cybercriminal syndicates.
Right. And the tactic is called Harvest Now, Decrypt Later.
What's fascinating here is the massive shift in attacker psychology.
How so?
Well, historically, the cyber attack lifecycle is pretty immediate, right?
You break in, you grab the stuff.
Exactly. You breach a network, you exfiltrate the data, you decrypt it if you can, and you monetize it right away.
And if you can't read it,
you drop it. You move on to an easier target.
Right. It's useless to you.
But Harvest Now, Decrypt Later is this game of immense calculated patience.
They are actively intercepting the transmission of encrypted data today, fully aware they cannot read it.
They don't even care that they can't read it. They are banking entirely on the inevitability of quantum maturity.
They're just hoarding the files.
Betting that the computational power to break those RSA and ECC algorithms will eventually exist.
So let's put a pin in the abstract math for a second. Let's talk about what this actually looks like in practice for you, the listener, or for a major enterprise.
Okay.
Because we aren't talking about stealing a credit card number here.
No. If someone harvests your credit card today but Can't decrypt it until 2035?
It doesn't matter. The card expired a decade ago.
Right.
But look at the types of data the source specifically flags. They list financial records, intellectual property, and government communications.
The really long-term stuff.
Exactly. Think about the research and development cycle of a defense contractor.
Oh, or a pharmaceutical company.
Yes. If you are designing a next-generation aerospace propulsion system, or, I don't know, synthesizing a new biologic drug.
That R&D pipeline is going to take 15 years.
Easily. So if a rival nation-state harvests your heavily encrypted proprietary blueprints today,
And it takes them 7 years to develop a quantum computer capable of decrypting it.
they still get your blueprints well before your product even goes to market.
The secret is out,
The structural damage to your organization is absolute.
even if it's delayed by a decade.
That drastically changes the threat model.
It really does. The vulnerability isn't just about what can be exploited today.
No.
It's about the permanent shelf life of the data.
And that creates this massive, almost suffocating feeling of urgency.
Because the data is already being harvested.
Right. If it's already stored in these dark server farms, the clock hasn't just started ticking. We are already halfway through the countdown.
We really are. For organizations holding this kind of long-term sensitive data, the consensus in the industry is crystal clear.
Waiting around is not an option.
No. Waiting for quantum hardware to become commercially mainstream is not a viable strategy. You just cannot afford to say, oh, we'll upgrade our network security when the quantum threat is fully here.
Because by the time the attacker has a functional quantum computer,
They already possess 5 or 10 years of your network traffic.
just sitting there ready to be unlocked in an afternoon.
Exactly.
So if we can't wait, what's the lifeline here? Because you can't just rip out the internet's entire security infrastructure overnight.
No, you break everything.
You can't just flip a switch and turn off RSA.
Right.
So the strategy that Zscaler and other leaders are pushing right now focuses on a transitional bridge.
And it's called hybrid cryptography.
Yes. Let's talk about that.
This is the strategic pivot, right? From the theoretical problem to the practical architectural solution.
Right.
Hybrid cryptography is defined as an approach that combines our traditional classical encryption with brand new quantum-resistant algorithms.
I like to think of it with an analogy. To make this relatable, it's like securing a vault.
Okay, let's hear it.
You leave the heavy, reliable, traditional steel padlock on the door because that's what your legacy systems know how to interact with.
Right, the guards know how to check that lock.
Exactly. But then you add this brand new futuristic force field lock right next to it.
That's a great way to visualize it.
You are securing the data transmission twice. Once for the classical threats of today, and once for the quantum threats of tomorrow.
And the source identifies the specific quantum-resistant algorithm being layered on top.
ML-KEM.
Yes, ML-KEM. This is really emerging as the standardized protocol.
But let's be clear about the operational reality here.
It's not free.
No, wrapping that tunnel introduces a significant increase in computational overhead.
A huge increase. You are asking your network infrastructure to perform substantially more complex math for every single secure handshake.
But here's where it gets really interesting.
Yeah.
Despite that overhead, the logistical genius of this hybrid approach is backward compatibility.
Yes. The primary emphasis in these industry discussions is that hybrid cryptography allows organizations to radically strengthen their security posture.
Without breaking their existing functioning system.
Which is critical, because if you attempted a hard cutover, if you just ripped out RSA overnight and replaced it purely with quantum encryption, the entire enterprise would collapse.
Yeah.
Your mainframes wouldn't be able to talk to your cloud environments.
Your employee VPNs would just fail.
Exactly. The hybrid approach mitigates that chaos. It allows legacy systems to continue functioning smoothly with the traditional encryption handshakes they recognize.
While seamlessly wrapping the actual payload in the quantum-safe protection of ML-KEM.
It's an incredible technical compromise.
And frankly, a necessary one.
If we connect this to the bigger picture, the friction of this deployment is exactly why events like the Future Ready Security Webinar are popping up.
The one mentioned in the Hacker News piece.
Right. They are drawing so much attention from IT leaders because chief information security officers aren't tuning in to learn the abstract physics of quantum mechanics.
No, they don't care about the physics.
They need to know how to deploy these massive, computationally heavy hybrid solutions in sprawling, highly complex corporate environments.
Without accidentally shutting down their own global operations.
Exactly. They need a roadmap.
So let's look at that roadmap. Let's walk through the actual blueprint.
The strategic blueprint out of this crisis.
Right. It involves a very specific set of actionable steps for organizations preparing for the quantum threat. Let's guide everyone through these.
Okay, the first step in the blueprint is essentially triage.
Identify the sensitive data.
Yes. Identify the data that absolutely must remain protected long-term.
Which requires a really hard look at data classification. You don't need to wrap the company cafeteria menu in computationally heavy quantum-resistant encryption.
No, you really don't. Or standard internal newsletters.
You have to find the crown jewels.
Right. The intellectual property.
The strategic merger documents, the biometric databases, the assets that have a strict confidentiality requirement spanning decades.
You prioritize based on the lifespan of the data's value.
Okay, so once you've identified what needs protecting, what's step 2?
The second step is arguably the most difficult. You have to understand exactly where encryption is currently being used across all your systems.
Wow. That sounds deceptively simple on paper, but...
In a Fortune 500 company.
Or a massive government agency, that has to be a logistical nightmare.
It is an inventory problem of epic proportions. You are trying to find every single encrypted connection in an environment that has likely grown through years of mergers, acquisitions, and decentralized IT purchasing.
Shadow IT.
Exactly. Where some department spun up their own secure cloud servers 3 years ago and just never told the central security team.
Or legacy servers sitting in a broom closet running critical but ancient applications.
Right. You have thousands of third-party vendor APIs connecting to your network. Encryption is everywhere.
And it's often undocumented.
Completely. And you cannot upgrade the protocols until you have comprehensively mapped that entire terrain.
Okay, so map the terrain, that's step 2. Once that is done, the third step is the actual deployment.
Right.
Beginning the adoption of those hybrid cryptography strategies.
Rolling out ML-KEM.
Exactly, rolling it out across those critical data paths you identified back in step 1.
Which brings us to the fourth step.
Maintaining visibility.
Yes, maintaining deep visibility into your cryptographic algorithms and your compliance needs.
Because after you deploy these new hybrid protocols, the environment doesn't just freeze.
It's not static at all. You have to continuously monitor the network to ensure the ML-KEM layers are functioning correctly.
That they meet evolving compliance frameworks.
Then that no legacy system is accidentally reverting to purely classical encryption and exposing the data.
Wait, hold on. Let's look at the reality of maintaining that visibility for a second.
Okay.
Because if I am successfully implementing all of this, if I map my network, I deploy ML-KEM hybrid encryption, and my data is perfectly wrapped in this futuristic quantum-proof tunnel,
Yeah.
haven't I just created a massive blind spot for my own organization? I mean, if I make my data so dark and secure that a nation state with a quantum computer can't read it, how is my own internal IT security team supposed to scan that traffic for a basic phishing virus?
That is the big question.
How do they inspect the tunnel to ensure an employee isn't maliciously exfiltrating the source code to a competitor? Haven't we just locked ourselves out of our own house?
You've hit on the critical architectural complication, and it is a major focus of the text.
It has to be.
By making the data perfectly dark to external attackers, you absolutely risk making it perfectly dark to your own internal defenders.
And security teams still have a day job.
They do. They are required to inspect encrypted traffic, detect malware, block insider threats.
Enforce data loss prevention policies at scale.
All of it. So you cannot blind them.
So how is that resolved? How do you maintain an unbreakable, quantum-resistant encryption tunnel across the public internet, but still allow your own security infrastructure to look inside and validate the traffic?
The solution lies in modern network architecture, specifically zero trust architectures.
Okay, let's contextualize how zero trust integrates here, because it fundamentally changes the old perimeter defense model.
Right, the old castle moat idea.
Exactly. We are moving away from the concept of a trusted internal network. The idea that once you are past the firewall, you just have free reign.
Zero trust assumes the network is always hostile.
It demands strict authentication and authorization for every single device and user.
For every single transaction.
Regardless of whether they are sitting in the corporate headquarters or at a random coffee shop.
And in the context of the post-quantum problem, zero trust architectures are the key to maintaining control over this heavily encrypted traffic.
The Hacker News overview specifically details how platforms like Zscaler are doing this, right?
Yes. They are implementing these zero trust models directly alongside post-quantum traffic inspection.
So the platform acts as the intermediary.
Exactly. When an employee sends a file using ML-KEM hybrid encryption, the zero-trust architecture is designed to safely terminate that secure tunnel at a highly secure, cloud-based checkpoint.
A checkpoint, okay.
It opens the heavily encrypted hybrid tunnel for a fraction of a millisecond.
Just long enough to look inside?
Right. It inspects the traffic for malware, validates the user's identity, and ensures the action doesn't violate any data loss policies.
And then what?
Once the traffic passes inspection, the platform instantly re-encrypts it using the hybrid post-quantum protocols and sends it to its final destination.
Wow. So it serves as this incredibly fast, secure checkpoint that speaks both languages.
Yes.
It understands the traditional need for deep packet inspection and policy enforcement, but it is fully capable of handling the immense computational overhead of the quantum-resistant encryption.
It allows the organization to enforce their security rules without breaking the quantum-safe protections they just spent so much time deploying.
That is brilliant.
It really highlights the role of modern architecture. The defense is no longer just about building a stronger wall.
Right.
It's about creating an intelligent, highly scalable fabric that can manage complex encryption routing on the fly.
Because security vendors have to provide environments where this heavy hybrid encryption can be inspected and managed without introducing massive latency.
If it grinds the business to a halt, no one will use it.
Exactly. So what does this all mean? I mean, if we step back and recap the entire scope of what we've unpacked today, we're witnessing a fundamental pivot in digital defense.
We really are. Quantum computing is going to fundamentally reshape cybersecurity.
We started with the chilling logistical reality of the harvest now, decrypt later tactic.
Attackers are currently stockpiling our encrypted data.
Playing a long game of patience, betting everything on a quantum future to unlock it. The threat is not a decade away. The interception is happening right now.
But the proactive solutions are equally sophisticated. We aren't paralyzed by this.
No.
The deployment of hybrid cryptography, specifically utilizing standards like ML-KEM, offers a vital bridge.
Right. Layering futuristic protection over existing legacy systems.
Without tearing down the operational infrastructure. And by pairing those hybrid encryption standards with modern zero-trust architectures.
Enterprise security teams can defend their data against quantum capabilities without blinding themselves to internal threats.
The organizations that prepare early, the ones mapping their terrain, adopting ML-KEM, transitioning to zero-trust right now, they are the only ones who will successfully secure their most critical assets.
It's a huge shift.
It is. But, analyzing this leaves me with a thought that builds on all this. And it is genuinely difficult to shake.
Oh, what's that?
Well, we have spent this time detailing what organizations must do to secure their data moving forward, right?
Yeah, the blueprint.
But if sophisticated threat actors have already been executing this harvest now, decrypt later strategy for years.
Vacuuming up petabytes of data while we confidently relied on our RSA and ECC algorithm.
Exactly. If they've been doing this for a decade, how much of the world's heavily encrypted digital history is already sitting on an attacker server farm somewhere?
Oh, wow.
Just think about it.
Yeah.
How many years of corporate strategy, intellectual property, private government communications go? How much of that is already piled up in a dark database?
Just waiting for the day a quantum processor finally comes online to turn the lock.
Exactly. Waiting for the key to turn.
That is a staggering question. It completely reframes how we have to think about the permanence of our digital footprints.
Yeah, it really does.
The past might already be compromised. The only thing we can control is the architecture of the future.
That's the reality.
Well, to you listening, thank you for joining us on this deep dive. We've covered an immense amount of ground today, from the delayed fuse threat of quantum computing to the complex architectural defenses being deployed to neutralize it. Keep your curiosity sharp, stay engaged with the shifting landscape, and remember that in an ever-evolving digital world, being deeply informed is your best defense. We will catch you on the next deep dive.